2.4 is about the average rate of change. So by the end of today, you're going to be able to calculate the average rate of change of a function between 2 points. Do you guys know another word for the average rate of change? No. You say no for something? Yeah, the slope, right? Okay, the average rate of change between 2 points is going to be the slope. And the slope that we're going to find is not necessarily for a linear function, but if you have different functions, you find the slope of the secant line. And that's what that first information box is going to help you make sense of. So remember, you do have a college textbook, so it's important that we are interpreting what these are telling us. So I'm going to give you a second just to read over that information box. Trusty highlighter out. So this box is all about the average rate of change. It's important to note that they tell us that the average rate of change is the change in y over the change in x. And then we have this formula that the f of b minus the f of a divided by b minus a, that's going to be our rate of change. I'm actually going to show you how that is linked to our slope formula. So this is our average rate of change. How do you guys think that you did on interpreting what's happening in this picture? That good, huh? I mean, when you see this, what do you think? That, yeah, rise over run, right? You can see the rise here, the run here. Sometimes it's kind of confusing, right? To know there's f of b, f of a and b. There are all these variables in a bunch of different places. So we just kind of have to take a step back and do it one thing at a time. So the first thing I notice is a and b are on the x-axis. Okay, so a is just like our x1 value. B is just like our x2 value. And then the output is going to be the height of the graph. Remember we did that yesterday when we found the value of the function? So if this is x sub 1, this is our output. We can call that y sub 1. Our output for our b value or our x sub 2 is y sub 2. So the rate of change, or I say the AROC, average rate of change, is y2 minus y1 over x2 minus x1, which is what you are used to seeing as your slope formula. So it really is just finding those 2 points and then finding the average, or the change in y over the change in x. You can also think of your y's as your outputs and your x's as your inputs. If a is our input, does it make sense to you that f of a is the output? So if a is what you're plugging into the equation, would f of a be your output? Yeah. If you're plugging in b, would f of b be your output? Yes. So really what this is modeling is, do you guys know the symbol for change? Yeah, the triangle, right? Okay, so this is going to be the change in your output values over the change in your input values. And then as we go on today, I am going to try to help you make sense of this equation and how it relates. But a lot of times you are just going to be thinking of it as the change of the output over the change in the input. So today, for example 1, you're going to be given functions and you're determining the average rate of change between those given values. So we need page 177, number 5. And once you get there, you're going to see that it is a graph. Okay, so instead of giving you an awful photocopy like last time, we're just going to use this beautiful picture here. Okay, so in the directions for 5, it says that we're going to determine the average rate of change between the indicated points. So for number 5, you should be able to identify those indicated points. They're on the graph. Will you write down your indicated points for me and then find your average rate of change? Okay, if you don't have your book, just share with the person next to you. Okay, so Cameron, what are your 2 points from this graph?
4, 5.
Good, okay, so your 2 points, 1, 3, and 4, 5. Okay, so your average rate of change is going to be your change in x over your change, your change in y over your change in x. So I am going to think of these as x1, y1, x2, y2, and do 5 minus 3 over 4 minus 1. Now, if I switched them around and did 3 minus 5 over 1 minus 4, would I get the same answer?
Yep. Yes.
Okay, let's see. So 5 minus 3 would be 2. This would be 2 over 3, so that's my average rate of change. If I switched it, I'd have 3 minus 5, which is negative 2. 1 minus 4, which is negative 3. What's a negative over a negative? A positive. You guys couldn't give me a heads up or anything? Sorry about that. Okay, so 1, 3, 4, 5, and then you are finding your slope, so you should have 2/3 there. Okay, and then let's go to number 11. So we're going to step things up a bit. You guys ready? Alright, so you are given h of t, and h of t equals t squared plus 2t. T is going to equal negative 1, and t is going to be 4. Okay, so this is how I'm going to show you that we're going to use our formula. Alright, so our formula is technically your f of b minus your f of a over b minus a. Your a value is simply what's given first. Your b value is what is given second. Okay, so in this case, my a value is going to be negative 1. So you could think of this as a equals negative 1, and you could think of your b value as 4. So that would give you the denominator, right? Your b minus a. So what we have to do is find f of b and f of a. Now we use f because usually your function is f of x, but this isn't f of x, this is what? This is h of t. So when we're finding f of b, okay, we're actually going to be plugging in, what is our b value? 4, okay? So we're going to find h of 4. And again, the only reason why it's h is because the function is giving us h. Okay, so b is equal to 4, so I substituted that in. Instead of f of x, we have h of t, which is why I'm going to plug that in. So now if I need to find h of 4, Dennis, how do we find h of 4? Exactly, so we're going to plug 4 into our t value. So it'll be 4 squared plus 2 times 4, and I'll let you figure that out. And then we're also going to have to find our f of a, which is really h of negative 1, and I'm going to let you find that one. Okay, so Carmen, what is h of 4 going to be? 24. Okay, and then Kenny, what about h of negative 1? What did you get for that?
That would be 1.
Close. Right, because you have negative 1 squared, which is
That would be
1, and then 1 minus 2 would be?
That would be negative 1.
Yeah. Okay, so really, you can think of these as points. For the first one, what did I plug in? For this one, what was my input? 4. What was my output? 24. Okay, for this one, my input was negative 1. What was my output? Negative 1. So when I do my change in y over my change in x, okay, or my f of b minus f of a over b minus a, really, all I'm going to be doing is 24 minus negative 1, and that would be over 4 minus negative 1. What happens when you have minus and negative? Turns into plus, so it's really 24 plus 1 over 4 plus 1, so 25 over 5, which of course will simplify to 5. Okay, so when you're doing this on your homework, you don't have to write out all this work. I just want you to understand how this is related to your equation, how you're using that. Okay, so you just have to see that the input's negative 1, so you could just write down your point, because I'm confident you could plug that in your head. Okay, so negative 1, 1, 4, 24, I would just expect to see those 2 points and then your work for solving it. Okay? All right, 17. For 17, we are given that g of x equals 1 over x, and that's when x equals 1 and x equals a. Okay, so for this one, I'm not even going to label them. Okay, I just have my 2 input values, and Ryan asked, what are my 2 input values? 1 and a. So I have to find my 2 output values, which are going to be g of 1 and g of a. Okay, do you think you guys can find g of 1 and g of a? Okay, so Michaela, what did you get when you plugged in for g of 1?
I got 1.
1, so it's 1 over 1, which is going to reduce to 1. Excellent. Mitchell, what about g of a? 1 over a. Okay, so our 2 points, let's write what the point's going to be. So we plugged in 1, we got out 1. 1, 1 is going to be our point. For this one, we plugged in a, we got out 1 over a, that's going to be our other point. So from there, do you think you guys could do the setup for the change in your outputs over the change in your inputs? Some of you already do it? plug it in? Okay, when you tell me what you got.
Well, 1 over a minus 1 over a minus 1.
Okay, good. So your average rate of change is going to be 1 over a minus 1 over a minus 1. What do you guys think? Are we going to leave it like that? No, because that's 1.4, right? So we're going to simplify. So let's start by simplifying the numerator. Actually, I'll give you a minute to do that. Okay, so go ahead and try to simplify the numerator. So you want to make it one term. Okay, so Kenny, what's your LCD going to be for the top?
It's gonna be, A.
Yep, okay, so you have 1 over A, and then this would be minus A over A, right? Okay, so then tell me what the next step would be.
You'd subtract, so it'd be 1 minus A over A.
Good. How did you know it was 1 minus A and that you couldn't subtract them at all?
Oh, because they're not the same.
They're not like terms, right? Okay, so 1 minus A is not 1A. Okay, you have to leave it as 1 minus A. And then, of course, all of that is over A minus 1. Okay, so now what we have is a complex fraction. So we have 1 minus A over A divided by A minus 1. So now if we're going to divide fractions, we have to multiply by the reciprocal. So this would be 1 over A minus 1. Did some of you get to that point? Okay, good. So now we're going to multiply straight across. And this part is going to be the tricky part. Okay, so I'm going to leave it like this for now in factored form. And that's because we do have the possibility of a cancellation. So I have 1 minus A on the top, I have A minus 1 on the bottom. Those look kind of similar, but not exactly the same, right? So let's analyze our numbers. We have a positive 1 on top, we have negative 1 on bottom, we have a negative A on top, and a positive A on bottom. So what is the relationship between those? 1 and negative 1, A and negative A. We'd say they're what? They're opposites, right? One's positive, one's negative. How or what can I do to make them sort of the same?
Take out -1.
Okay, yeah, so you can factor out a -1. Did you guys realize that? That was the tricky part, right? So I'm actually just going to write a note as well. Okay, so factor out -1. So when you do that, when you factor out that negative, it's like you're dividing by a negative. If you divide 1 by a -1, what do you get? -1. So I'm going to keep that at the back. And then negative A divided by a negative is going to be positive A, and I'm going to put that in the front. Why would I want to write it like that? Yeah, so I want it to match the bottom, right? And then that's in standard form. Your variable first, your number term second. Okay, so now from this step, is it clear to see that you can cancel those out? Yep. And I'm just going to write it again and then cancel it out, so if somebody is reading the notes, they can see those two steps clearly. And then, Isabel, when everything cancels out, what gets left in its place?
-1 over A.
Okay, yeah, so the 1 is going to be on top, so it'll be -1 over A. And that will be your average rate of change. Wasn't that fun? So many things in one little problem. All right, let's go to the back. So we're gonna look at page 178, number 27. I'm gonna give you a minute to read over some of that. Okay, Jory, what is this question talking about?
Number of CD players sold.
Exactly, yep, so the number of CD players sold. So, CD players are these things, they play compact discs, I don't know, do you guys have any of these things? Used to, the CD singles. So the CD player sales are labeled in your chart by year and then by how many sales there were. And for part A, we have to find the average rate of change from 93 to 2003. Okay, so what you can do is you can think of that like a point. So in 1993, Marla, how many CD players were sold in 1993? Good, 512. And then in 2003, Sarah, how many CD players were sold? 584. So we're going to find the average rate of change between those 2 points. So I'm going to give you some time to do that. Okay, so in 93 there were 512. In 2003 there were 584. And feel free to move on to the next one if you finish that one quickly. So for the first one, I wrote out the equation that I was using, the 584 minus 512 over 2003 minus 1993. The change in your x values is just going to be the change in the years. So you guys are going to be able to do that mentally. So between 2003 and 1993, how many years had passed? 10, okay? So we know it's going to be 10 on the bottom. And then you guys can subtract. So 4 minus 2 is 2. 8 minus 1 is 7. So we have 72 over 10. You don't even need a calculator for that one, because what do you have to do when you divide by 10? Let's move the decimal place 1 to the left. Okay, so we have 7.2, and then we're going to label that as CD players per year. So make sure you label your units. That will be the same on your test. And so you will have points for being able to label your units. So make sure you practice that. So the rate of change means 7.2 CD players per year, which means between 93 and 2003, what happened? What was the average rate of change? Okay, so each year, it increased by 7.2 CD players. Okay, so that's the change between them. All right, and then the next one we did from 93 to 94. Did you guys already do that calculation? Okay, so with this it was just 1 year, so 1 is your denominator. 520 minus 512 is 8, so you should have 8 CD players per year. Okay, and then for C, something different happened. Mitchell, what'd you get for your average rate of change?
Negative 90 over 2.
Okay, let's go over it. So you had 94, there were 520, and 96, there were 410, right? Okay, so when you're subtracting them, do you guys add up to find out what it's going to be? So like to get from 410 to 510 would be 100, right? And then from 510 to 520 would be 10 more. So it'd be 110. And that would be positive or negative for this? Negative, okay? And that's because the bigger number is going to be negative over 2. So half of 110 is 55, so it's negative 55 CD players per year. So the average rate of change between 94 and 96 was actually a decrease, right? Okay, so it went down 55 CD players per year. All right, and then it says fill out the rest of the table by finding the rate of change for each year for D. And then there's also another question in your book that we're going to answer. So I just put the years there first. Now when you're filling out the table, the change in X is always going to be what number? It's always going to be 1. So really, what's the only thing you have to do for those?
Subtract
You just have to subtract or find the change in,
sales.
find the change in your Y values. Okay, so I'm going to give you some time right now to do that. Once you fill out the chart, we are going to answer that question in part D. So if you want to go ahead and do that, that's why I have the little solution there. Are we ready to check to see if we filled out the chart correctly? Starting with 94, 95. Okay, so for 94, 95, you should have negative 107. And then negative 3. 58. 42. 80. 17. 125, negative 120, and negative 28. How did we do with that? Good. Okay, and then Ben, can you read for us what part D is asking us to find?
Between which two successive years did CD player sales increase most quickly and decrease most quickly?
Okay, good. So we're trying to look for most quick increase and decrease. Noel, looking at our chart, what do you think? Which 2 years did it increase the most quickly?
2000 and 2001.
Yep, and how did you know that?
It's the biggest positive number.
Exactly, it's the highest positive value. Okay, Caleb, what about when it decreased the most quickly?
From 2001 to 2002,
Good, and how did you know that?
because it's the smallest value.
That's right. 01, 02, great years we got there. Those were the years, that was when I graduated high school.
That was when we were born.
I know, that's when you guys were born. Okay, so the increasing interval would be 2000 to 2001. Your decreasing interval is 01 to 02. And that's why I wrote solution on your paper, so that's where your solution is. Okay, so you have the increase and the decrease. And for this one, I don't know why, but I put them on this side. So increase most quickly and the decrease most quickly. So 2000 to 2001. And then 01 to 02. All right, and then we're going to look at example 3 on page 179 and number 30. And I'll give you a few seconds to read over that. Okay, so Blake, what is number 30 talking about on page 179?
So you want to find like the average rate of, wait, are we talking about just like in general?
Yeah, just in general. Like, what is that chart showing us?
The number of farms from 1850 to 2000.
Yep, exactly. So the number of farms from 1850 to, what was the last year?
2000.
Okay, so we're going to be finding the rate of change in the number of farms. So the farms that were either gained or the farms that were lost. So they give you, for part A, they give you 2 parts, a 1 and a 2. Max, for part 1, what do we have to find?
You have to find difference in price between 1860
Yep, 1860
and
and 1890. Okay, so between 1860 and 1890. So how many years are there between 1860 and 1890? 30 years, so that's going to be our denominator. And then we're going to have to find those output values, which I am going to help you do. So you can kind of see that there are points on your grid. So we're going to go to 1890. Okay, so 1890 would be right above your 1900. Okay, so it looks like it is going to be this point here, correct? All right, and that looks like it's about where? 4,500. Yep, great. Okay, and then the other one is 1860, and you can see that point, it's right here, and that looks like it's at, where does that one, where does that point go? 2,000. Okay, so we're going to have 4,500 minus 2,000 over 30. And then we are going to round our answer to the nearest farm. Okay, so 4,500 minus 2,000 is 2,500. If they both end in 0, you can just go ahead and cross off those zeros. So really we can just divide 250 by 3. And then you should get a decimal. Did you guys get 83 1/3?
Yeah.
Okay, so we're just going to round that down to the nearest farm. And so you're going to describe for me what that means. So there are 83 farms gained per year in that 30-year time period. Okay, so the average rate of change is 30. There were 30 more farms, or 83 more farms gained per year over those 30 years. Okay, and then we're going to try part 2. So Lucas, for part 2, what are we trying to find?
The number of farms gained or lost between 1950 and 1960.
Okay, so 1950 and 1970. Okay, so for 1970, looks like I'm right here. So I'm going to follow that across. This one, it looks like we may have to estimate, right? Because it doesn't look like it's exactly on the 3,000, but it definitely looks like it's above the 2,500. What would you guys estimate? I would estimate either 2,800 or 2,700. Either one of those would be fine. I think I did use 2,800, but I would be perfectly fine with 28 or 2,700 as well. Okay, so then we're gonna do 2,800 minus 5,500. This is for part 2. I'm just gonna do it with you. So 2,800 minus 5,500, and then there were 20 years in between those. So we get negative 2,700 over 20. You can cancel those out. What's half of negative 270? What's half of 200? 100. What's half of 70? 35. So it would be negative 135. So it would be 135 farms that were lost per year. Okay, so between those, that's how much it decreased by. Okay, and then for B, Shawan, what is part B asking us to do for this?
It's asking for the year that there was the greatest average.
Good.
decline.
Yes, so when is there the greatest average of decline? So when you're looking at your graph, what are we looking for? Okay, so the steepest drop, right? So everything that's on the left side of the graph looks like it's going up. So I'm going to look here. Which one is going to be the steepest drop? Good. So 1950 to 1960, which is right there. And that will be your steepest decline, 1950 to 1960. All right, and then I'm going to give you your homework. And then we're going to go over the piecewise graphs on your Chapter 2 review or intro packet. And then we'll, after we look at those, we will do some presentation.